Hey guys, welcome back to my garage. I'm getting back on this Supermax YCM40. I'll do a little walk around, kind of catch you up on what I've been up to. Pretty much I've been trying to sort out the power drawbar, put the lines back on it, they were missing, put the spindle motor back on it, kind of cleaned up the table, and kind of prepping things on the machine itself to accept the new control. It'll be a Centroid CNC all-in-one DC, just like the other mill that I did. I wanted to go ahead and kind of give you guys an update on what's going on. So let's do a walk around, I'll show you what I'm doing. Okay, we'll start at the top. I've got the power drawbar remounted on the head and the spindle motor. Those had to come off to make it through my 7-foot garage door. This head does not tilt like a typical Bridgeport. I've got the air lines replumbed, but I have, when I tested the valve here, I've got some air escaping here. If anybody knows the YCM40 Supermax, I'd like to know how this thing is supposed to operate. You know, basically the air comes in here, comes down into the valve. I don't know if it's a 4-way or a 5-way. It's got a 120 volt solenoid right here, and then 2 air lines come out. One is going up to a spindle brake, and the other one tees off from the spindle brake down and then feeds the power drawbar. There's the cabinet. It's a step-down transformer for the servo motors. This thing does not use straight rectified AC. The motors on this machine, their terminal voltages are much less than rectified AC. So I have to have the transformer, and that's the original one that came with the machine, so I'll be reusing it. Okay, over here I've got the back panel out of the control cabinet, and here you see the all-in-one DC. It's mounted up. That's a Tico FM100 drive. It's a 7.5 horsepower drive. The spindle motor on the mill is 5 horsepower. I'll be feeding it with single phase. I know these FM100s will take single phase input, so that's why it's actually a little bit bigger than is needed. Up here you can see some fuse blocks, the 15 positional terminal blocks, the e-stop relay there, and of course the bridge and the capacitor for the DC power supply for the. So I've got this thing all laid out. I've got the Panduit all put in place, and I'll be bench testing this here pretty shortly. As far as the details on this build, it's very similar to the larger knee mill that I did in very detail, where I installed a Centroid all-in-one DC. So you might want to go back to that and watch that. I'm just going to kind of hit some highlights of this machine as I go, and show you what I'm doing that might be a little different or a little bit unusual to the Supermax. Okay, what I'm going to do here, this is the X-axis servo motor. I need to determine if it has an encoder in it, and what the value is. Hopefully I can get a tag and read the information off of it. This one I know has a tachometer in it because it says right here it has a tach. I believe that this machine used encoders as well. In fact, I'm sure of it. So there's probably a tach and an encoder, judging from the thickness of the caps on the servo. Here are the brushes here, so this section here is, you know, probably where the encoder's at, and a tachometer, and obviously here's the MS connector here. So I'm going to carefully take the MS connector off of it, take a peek inside, see what we got. It's an effort in seeing if we can reuse the encoders that were on the servo motors. You can always reuse the servo motors, but the encoders are what's questionable. Get a mallet to tap that off. Okay, I've got a dead blow hammer here. There it goes, popped right off. Okay. See if we can swing this out of the way. Let's take a look at what we got here. we have an encoder, and just says Rotary Encoder, gives me the connections, and a part number. And I have a dash 1000 BZ1-5L on it. So that's, I'm guessing that's probably a 1000 line encoder on this one. And the tachometer is probably underneath this housing here. Since I'm not going to use a tach, you know, I'm not going to do anything else. I'm not going to go in deeper to fool with the tach. I'll just leave it. But I'll look this encoder up on the internet and see if what I can find out about it. It does have where it says connections. I'm not sure if I can show you this, but on connections it does have an A, an inverse A, a B, inverse B, a Z, inverse Z. Black is 0 volts, red is VCC. It's a heads HEDSS encoder. So, you know, there's a good chance I can reuse that encoder. So I'm going to look it up and see what it says. Okay, what I decided to do is I couldn't find very much information on this encoder. I'm guessing it would probably work. It's only a 1000 line encoder. But because of the Centroid recommendations for 2000 lines and above, I'm going to go ahead and swap it out. So I'm going to go ahead and pull the encoder off. And there are 2 set screws here. Trying to get this where you can kind of see what's going on. Turn the shaft, get to the other one, loosen it. There's 1 screw. Still might make a good encoder for another project. Okay. There's the encoder. You can see it's got the proper colors. And there's the part number. I'm guessing I've seen that dash 1000 BZ is probably a 1000 line encoder. Here's a Tamagawa encoder. It's a 2000 line encoder, 5 volt. It's an incremental encoder, differential output. It has the same connector as the heads encoder. The color code appears to be close. I'll probably replace the MS connector with a cap. This is an MS connector. I'll probably take it off, put a cap and a strain relief, and then bring my encoder lead out and my power lead out. So let's go ahead and put this one on. There are two flats on this one. Okay guys, I accidentally left my microphone off when I did this little clip, but the point of this video was just mounting the encoder to the servo motor. That the encoder itself is mounted to the servo motor body first before its shaft collar is locked to the stub on the servo motor. The encoder itself has a springy mount, give it some flex, so it's best to mount the encoder to the motor first and then tighten up the shaft collar. This wire is a ground, and it goes through the encoder mount. Just double checking that both screws are snug. And now I'm locking the encoder collar to the servo motor stub. And there are 2 set screws on it. You don't have to herc down on them, they just need to be snug. Now that the encoder's installed, I mean, I can connect this, but I think I'm going to go ahead and order some new encoder cables from Centroid. and do away with the MS connector like I had previously mentioned. So, but just to keep everything organized and in order, I think I'll just put it back together till those cables come, and then I'll swap them back out. Okay, that's the X-axis, got a new encoder on it. I'll go ahead and set this one aside, and we'll pull the Z-axis motor off of it, and we'll open it up and take a look at it. Okay, here's the Z-axis motor. It's another SEM motor. It's got this cable. I'm telling you, it's got to be 16 freaking feet long worth of seal tight here. Let's get this cap off and see what we got underneath. If there's a jacketed cable, I may just remove the seal tight. I suspect, I don't know, it's an SEM motor. Maybe this machine's had motors replaced in its past. The other one was a Servo Dynamics, but they're just SEM motors as well. I'm guessing this has probably got a 1000 line encoder on it as well. Okay. That's an interesting encoder. It's a hub type. It's a hub type encoder, and then it's got a coupler here. Yeah. I bet this is a 500 line encoder. Dynamics Research. I'd say it looks like it might be a 500 line encoder because it has a -500 here. So it looks like I'm going to have to replace this one as well. This one's probably not going to be as easy to replace. I pulled the seal tight off the back cap, and I found this small cable here, and that's going to the tachometer, that's just underneath the encoder here. So yeah, it had a tach. Now it's a matter of deciding what to do with it.